Well, 2 more days of finals, and if you are watching this video, then you're in my period 1 class, and you've got your final tomorrow morning. The scores were pretty good today, so if you are studying diligently, then it should pay off. Just got to be careful about the little things. This is one of those problems in which it's got bigger numbers. It doesn't have answers that you normally see. Normally you have to work it all out, but in this particular case, the answer is just setting up the equation, and I've done much of it for you here already, so I just wanted to make sure we're in the right place here. Final Exam Study Guide, Part 3, problem number 98. And we start with, it says 200,000 people, and then 6 years later, that number of people has grown to 834,000. And it's asking you to basically set up an equation, set up a function to determine in how many years what the population or how many people would visit the amusement park in later years. So this is kind of a little bit different way of asking the same question. Usually you hear something like, if this number of people visited in the 6th year, how many people would visit in the 10th year or the 11th or whatever. So anyway, the beginning of this problem is just figuring out what's being asked and setting up the equation using n sub 0 times e to the kt. That's equal to n being the number or the population at time t. I indicated here that the population at time 6, which I can use n sub 6, was this population here. We talked about that. The initial population was 200, and then again the 834,000 occurred at the 6-year mark. In other words, when t is equal to 6. So that's where that 6 comes from. And then in solving the equation, I'm just going to divide both sides by 200,000. That's what that k is for, represents just shorthand for 1,000. And when you divide both sides by 200,000, you get the e to the k e to the 6k. Maybe that's a bad choice of letters here in this problem to use that k there. This k right here represents the number 1,000, or a multiple of 1,000. And so it cancels there. 834 divided by 200. I should have done that before I did the video. My apologies. But I've got my calculator right here. 834 divided by 200, that's 4.17. And where is that going to come from? Oh, 4.17. And then I'm going to, let's see. I'm going to store that value. Let's go ahead and write it down. Okay, so it's 4.17 there equals e to the 6k. And as you see right up here, by the way, thank you to Connor Hadley. I didn't realize I could include text up here and type it in. It's a lot easier. Anyway, at this point, we're going to go ahead and take the ln of both sides because we've got to solve for k. And by taking the ln of both sides, the e goes away. I'm also going to divide both sides by 6. And that's going to be our value for k. And if you look up here, looks like it's either going to be 0.238, 0.248. It's one of those two. And so we have ln of that answer, 4.17. And we're going to divide that by 6. It's 0.238. Okay. So that's what k is. K is 0.238. And I should put a squiggly equals. Well, that's our magic number there because that's the number that's in the equation over here. And then going back to the original function, we'll let it be f of t, and normally we put a big capital N right there. equals, yeah, that's 200,000, because 200,000 is the initial population. Okay, and multiplied by e to the k, which is 0.238 times t. And which one is that? That's A. First choice over there on the left. There you go.